Okay, welcome guys back into another video. In this video, we are going to talk about the pinnacle coupling or pinnacle rearrangement. So this video I'm going to discuss based on two perspectives, right? First, let's talk about the reaction and mechanism, how this reaction proceeds. And then let's talk about the retrosynthesis analysis, how this reaction occurs in our retrosynthesis analysis, right? How the questions occurs in how the question occurs based on this particular reaction. So if your level doesn't do anything with the retrosynthesis, like if you are not following retrosynthesis course, then only the first half of this video will be efficient for you, right? So don't waste your time for watching all the full-time video if you are not following the retrosynthesis analysis, right? Okay, now let's move on to the reaction. First, you need to understand this reaction. Okay, let's take a ketone. Here you have a ketone. If you have add magnesium with benzene, right, with water, and you are going to heat it, and then you can obtain this particular product. Okay, you are going to add two of these molecules together with two OH bonds here. So this is a diol, right? This is a diol. Now if you add a Lewis acid, OH plus, okay, let's say you are adding a acidic medium, you are using an acidic medium. So now what can happen is, this one of these hydroxyl groups can go and attack to your protons, and it can form water molecules. Here you can see now it has formed this. This is positive. Now this is a very good leaving group, so this can leave on its own. So we are left with this particular molecule. Okay, so here we have a negative, sorry, positive charge. Okay, now this is the structure we have obtained up to this point. Now there can be a rearrangement, right? There can be a rearrangement. So this rearrangement we call as a pinnacle rearrangement. So this particular methyl group, right? Like these are methyl groups, right? These are methyl groups. These are methyl groups. So there's a CH3 here, and there's a CH3 here. Likewise, these are methyl groups. So these methyl groups can shift up to this place because of the electron pushing from this particular oxygen. This oxygen is going to form its double bond, like its pi bond with this carbon. So this carbon is going to destabilize, right? It cannot contain 5 bonds. So either one of these bonds has to be broken. So this methyl groups is going to shift to this place to give the available space to form this pi bond. Now we have the structure like this. We have formed double bond oxygen, and there's a methyl group, and this is the newly shifted methyl group. Okay, this is the newly shifted methyl group. So you need to understand this particular reaction. So I'm not going to talk about the mechanism, this particular mechanism, right? So we will do a separate video for this particular mechanism. What I need you to understand is these steps. So this step and this step. These two are the most important steps in this particular pinnacle coupling, right? So you need to understand that. So let's move on to the retrosynthesis analysis. So again, if you're not following this course, retrosynthesis analysis, so don't waste your time here. But if you are following the retrosynthesis analysis, so this should be very, very valuable to you. But let's move on to retrosynthesis. Okay, now what about this molecule? You have a target molecule like this. Let's say you have this. Okay, this is your target molecule, and the final, like, you need to propose a retrosynthesis pathway to leads to this particular molecule. This is the molecule, the final molecule which you need to obtain from your particular retrosynthesis analysis. So I want you to think about it little, right? So this is based on the pinnacle coupling. This is based on the pinnacle coupling, and I need you to think about it. This is little bit a tricky question. Okay, so let's move on with the questions, right? I hope you have got some idea. Now, when I first look at this, right, and when I first see the tag, like the final molecule which I wanted to obtain, right, it's a little bit tricky path, right? It's a little bit tricky path. But if you look at your pinnacle coupling or pinnacle rearrangement process, right? You look at this process, this rearrangement process. You have a hydroxyl group, right? You have a hydroxyl group, or otherwise, let's say you have a double hydroxyl group here. This particular structure, right, is going to be converted into this step. This particular structure is going to be converted into a ketone like this. Okay, with the shift, with this methyl shift. Okay, so that particular reaction I'm going to introduce into this system, because like we have this structure, we have this 5-membered ring. So what we can do is, right, what we can do is, you can break the bond here, you can break the bond here, right, you can break the bond here and form this particular structure. Look at this. This is a diol, right? This is a diol. Look at this. It's just like the similar, right? This one and this one. So when I'm going through the pinnacle coupling, right? When I'm going through the pinnacle coupling, one of the hydroxyls will be removed. One of this hydroxyl will be removed, and positive charge will be formed here. So what happens? Another methyl group over here, or R group over here, will be shifted into this position. So you can see now, when a positive charge is forming on this particular position, either this bond or this bond is going to shifted into this place. So let me number the ring here: 1, 2, 3, 4, right? So when this particular bond shifted into this place, right, you can see we have obtained a 6-membered ring. Okay? 1, 2, 3, 4, 5, 6, 6-membered ring, which is this. So what I have done is, I have breakthrough here and formed 2 5-membered rings, right? I have break it from here and form a 2 5-membered ring. So let's move on with it. Now you know what happens here. Okay, the next thing is, this can simplified into this guy, just here, just from here to this initial place. That's what I have done in this particular step. Okay, I hope it's fine for you, right? You need to understand this this step, right? You need to understand this step. This is the very important thing. Like when it comes to questions, I don't think you will get very complicated questions, but this type of structure, right, this type of questions, this structure, right, this shape of the structure, like there is a carbonyl group here, and you can form a 5-membered ring from this 6-membered carbonyl carbonyl structure, right? That point, that particular fact you need to understand, right? There can be questions based on these particular points. So I hope it's fine for you. Now let's look at the synthesis part. Okay, when it comes to synthesis, we are going to start it with this, our 5-membered ring. So first, what we need is magnesium and benzene in the presence of water, and we have to heat it. So what happens now? Two of these molecules will come together to form a diol, right? So here I'm going to draw the diol. Here we have the diode. Now we have the diode. Now if you remember, we have to add the acid. So with this acid, one of the hydroxyl groups will be removed. Okay, so carbocation will be formed. Here we have obtained a carbocation. Now what happens? The rearrangement. Right? The rearrangement steps now happen. One shift will be happen. This will come to form a pi bond. So here we have the 5-membered ring and the 6-membered ring. Here we have the carbonyl group. So this is the target molecule. So it's not a very complicated thing, but you need to understand this particular step. This is the main step when it comes to this question, right? So this is a very popular questions. This is a very popular question when it comes to if you look at the reference books, like most of the reference books contain this example, right? So you will see this question very often. I hope it's fine for you. If you have any questions, please feel free to comment below. I will try my best to answer those. Uh, and that's it. So this is the pinnacle coupling. I hope you have obtained some amount of knowledge, and uh, I hope you understand.